Kia ora, Year 12. In this video, I'm going to quickly show you how to find a turning point on a curve using calculus. And then we're going to look at how to identify if we've got a local maximum or a local minimum. So this goes with Walker pages 28 to 30. And there's also lots of nice work on this in the theta textbook, although I can't remember which pages, and I've left that textbook at school in the holidays. So let's have a look, first of all, at the idea behind what we're about to do, and then we'll do 3 examples. So what I've got here is just some GeoGebra pictures of some parabolas and cubics, because these questions at level 2 will usually be about those 2 types of function. So this here is our familiar parabola where we've got a scale factor that is positive. For example, we might have y equals, 2x squared minus 6x plus 5. Now, that's definitely not what this example is, but the key thing here is that we've got a positive coefficient here. And you can see from looking where the turning point is. It's so obvious that it feels like, well, why do we need to do calculus to find it? And that makes sense. We can often find the turning point by just using algebra and graphing techniques. But in this video, I'm going to focus on always using the idea of the gradient function to find where the turning point is. So you can see the turning point is just intuitively where the graph turns around, right? Where it goes from having a negative gradient to having a positive gradient. And the turnaround place is the turning point. So what we're testing for is where is the gradient equal to 0? And then we're going to figure out if we've got a maximum or a minimum. So that's what we've got when we've got a parabola with a positive x squared term. This is where we've got a negative x squared term. But again, you can see where the turning point is. The turning point is here where the gradient is 0. And in this case, we've got a positive gradient here, and we've got a negative gradient here. The last one that I've done here is a cubic that's got 2 turning points. So the first turning point in here is around here, and the second one's around here. Now, just one thing to watch out for. When I find a turning point, I need to find both the x and the y coordinate. Okay, not just the x coordinate. And then I need to justify whether I found a minimum or a maximum. Now, we call it a local minimum or a local maximum for the following reason. What we're saying is in the neighborhood, what's the highest point here? So this is what we call a local maximum. We don't call it a global maximum because up over here, you can see that we've got some values of the function that are above this value here. Okay, so it's just a local maximum. In this area, it's the highest point on the curve. And the same thing here, we've got a local minimum here, because if you look over down here, we've got some points that are below this one here. Right, so it's called a local minimum and a local maximum, but you don't need to worry too much about that, but you might as well get used to that idea now. Right, let's look at 3 examples. So I've crossed out number 2 because it had really stupid numbers in it, but numbers 1, 3, and 4 should show you how to do this. So I'm going to work through number 1, and I've said here using calculus. Right, so not just by drawing that graph and going, hey, here's the turning point. So dy by dx for this first one is 2x plus 4. And that needs to equal 0 for a turning point. And this is how you need to communicate what you're doing. So we're going to solve that little equation. We get 2x equals negative 4, x is equal to negative 2. So that's good. And now we have to find the y value. So y is going to equal negative 2 squared plus 4 times negative 2 plus 6. So 4, take away 8, plus 6, which gives me 2. So the turning point is at negative 2, 2. 2 ways to find its nature. The first method that we can use, and actually usually the fastest at level 2, is to say the shape of the curve. What was it? Y equals what? X squared plus 4x plus 6. So it's a parabola. So the shape is like that. Therefore, at negative 2, 2, we've got a minimum. All right, so that's pretty easy, but I'm going to show you the other method, which is a bit more closely linked with the gradient function. Okay, so we can do a little table, and in the table we're going to put 3 points in. We're going to put the point that we've found has a gradient of 0. I'm going to write this now as f dash of x because it's slightly faster. Then I'm going to pick a point on either side. So I'm going to pick a point just below negative 2 and a point above negative 2. I'm going to be a little bit lazy here and pick 0 because it's always fast to work out the value of a function at 0. So f dash of x, the gradient function, was this here. It was 2x plus 4. So that's what I'm working out now. What's the gradient when x is negative 3? Well, it's negative 6 plus 4, which is negative 2. So that's negative, so the function's going like that. Here it's 0. And when we substitute 0 into here, we get 4. So we can see that we've got a minimum at negative 2, 2. Cool. Okay, a couple more examples. Now you can try those on your own first if you want, or you can just watch me go through them. So I'm not doing this one here. Don't do that one. Let's look at these two cubics. Now remember when we did graphing, there were a few different patterns for cubics. One went like that. One went like that. But sometimes we had this one, right? So this has not got, this is my basic one of y equals x cubed, drawn really badly. This has not got a minimum or a maximum in there, but what it's got is a point of inflection around here. So sometimes with a cubic, we'll find that there are no places where the gradient is 0, and that's fine. That means that we've got a cubic that's probably got a point of inflection, right? But I'm not going to get onto those in this video. Let's just clean some of this up. Okay, now let's look at this first one. We've got y equals x cubed plus 6x minus 6. So we start by differentiating. So dy by dx is equal to 3x squared plus 6, and that equals 0 for a turning point. So we're trying to solve 3x squared equals negative 6. X squared equals negative 2, and so that's got no real solutions. Right, there are no real numbers that when I square them will give me negative 2, so there is no turning point. And if you graph that, here's what you end up finding. Let's just hop over to GeoGebra, and I'll just see if I can get the right one. So x squared plus 6x looks like this. Right, so that's a cubic and it's got a point of inflection. Now while we're here, I'll show you what the next one looks like. So you can see this is example 4, and we're going to find 2 turning points in that one. So let's do that now. Right, so the next one is just about the same equation, but not quite. So when we differentiate this time, we are going to find turning points. So dy by dx is equal to 3x squared minus 6 equals 0 for a turning point. That gives me 3x squared equals 6. X squared is equal to 2. Right, there are 2 solutions to that equation. X is equal to the square root of 2, or x is equal to negative root 2. So how can I identify the nature of the curve? Well, I can use the shape of the curve method, and we've got a cubic with a positive coefficient. So it's x cubed, blah, blah, blah. So it goes up, down, up. So what does that tell me? Well, That means that the first number that I come to has got to be a maximum, and the second one has to be a minimum. So that's that. But I'm also going to do it using the table of values method so that you see again how that works. So what we're going to do is do two tables. So the x value that I'm going to put in here, I'll do this one here first, slightly faster because it's a positive number. So let's pick a number on either side of root 2. I'm going to pick 1 and 2. And remember, what I'm working out here is the gradient at those points. So the gradient here is 3x squared minus 6. We know that it's 0 here. So here it's going to be 3 times 1 minus 6, which gives me negative 3. So we've got negative here, we've got 0 here, and then at 2, we're going to have 3 times 2 squared, which is 4, take away 6, which gives me 6. So we have got a minimum at x equals root 2. But hopefully you've noticed there's something I've forgotten to do. I haven't found the y value. So we need to do that. So what is it? Well, I need to take root 2 and substitute it back in there. X cubed minus 6x minus 6. So that's going to be the square root of 2 cubed minus 6 root 2 minus 6. So you're going to chuck that in your calculator and it's going to give you the number that pops out, right? So you can work that out because I haven't got my calculator window open and this video is already getting really long. But that's what we need to do to find a turning point, right? It's not saying the x coordinate of the turning point, it's asking for the turning point. Now we need to go on and do that table again, but this time we're doing it for negative root 2. So just be really careful when you're working with negative numbers. So we've got x, and then we've got f dash of x. We're going to have the value where the gradient is 0. Then we're going to pick a number a little bit above that, so negative 1, and a number below it, negative 2. And we're substituting that in to 3x squared minus 6. Right, so it's going to be 3 times 4 take away 6, which gives me 6, which is positive. Here it's 0, and here we've got 3 times negative 1 squared, which is 1, take away 6, which is negative 3, which is negative. So we've found that we've got a maximum when x equals negative root 2. So there you go. So that was quite long, sorry about that. But what I want you to do now is go and have a good go at the Walker questions. It's worth reading through carefully the purple pages on pages 28 and 29, and then there are 5 questions on page 30. Thanks for watching, and I'll try and do some more videos over the next few days to get us through most of the achieved and merit skills.